In this video, we are looking at writing linear equations. By the end of our study, you as a student will be able to write a linear equation when given the graph of a line, 2 points on the line, or the slope and a point. You will also be able to use the point-slope form of a line to write the equation of the line. And you'll be able to write a linear equation when given a point on a line and the equation of a parallel or perpendicular line. So let's get started. To begin, we're going to provide a definition. The equation of a line passing through a point, we'll call the point P, and its coordinates are x1 and y1, with a slope of m, can be found using the point-slope form of a line. That form is y minus y1 equals m, and in parentheses, x minus x1. This is our third form that we've seen. We've seen standard, we've seen slope-intercept, and now point-slope form. It's called point-slope form because it has a point and the slope in the equation. So it's really useful. And we're going to use an example now and work with that form. We're asked to write the standard form of a linear equation passing through that point with a slope of 2/3. So we use the point-slope form. Substitute into that form what you know. The y value is 1, the slope is 2/3, and your x value is 2. Now, because you're working with fractions, it can be a little difficult sometimes. One thing you can do is clear the equation of fractions. To do that, you would multiply the whole thing by 3, which will result in no fractions remaining. That slope is now an integer value instead of a fraction. That's not a requirement, but it's just a really cool trick. And then we'll write it in standard form. So standard form looks like ax plus by equals c. So if you distribute the 2 to both of those terms in the parentheses, and then move your terms around, we have to remember that the first term should be positive, so we would multiply everything by a negative so that it is a positive ax by and then our c value. So it'd be 2x minus 3y equals 1. And it's written in standard form because that was what the question specified. Let's look at another example. Now we're going to be given 2 points, and from the 2 points, write the slope-intercept form of the equation of this line. To begin, you're going to find the slope. You have 2 points, so you can find the slope using the slope formula and substituting in. That would be 6 minus 3 over 2 minus negative 4, which is really in the denominator like adding 2 and 4. And that simplifies to 1/2. Now we'll substitute that slope of 1/2 and one of the points into the point slope form. So you just get to pick whichever point you like. There is the form, and we will substitute in that second point. 6 into the y1 position and 2 into the x1 position. Now we're going to solve for y because we want it in slope-intercept form. Slope-intercept is y equals mx plus b. So if you distribute the 1/2 and then add 6, you have the equation in the specified form. All right, definition here for you. Parallel lines, they have the same slope. So the slope of line 1, M1, would have to be the same as the slope of your second line, or M2. Here's one equation, y equals 2x plus 4, and its graph. It is parallel to the line, that green line. That green line's equation would be 2x minus 3. And they are parallel lines because they both have the same slope. Perpendicular lines have slopes that are opposite reciprocals. This red line is the equation y equals 2x plus 4 again. A line perpendicular to it would be that green line, which is y equals 1/2. That should be a negative 1/2 x minus 3. Negative because you have to be opposite. The red graph is a positive slope, so you'd have to have a negative slope. And the reciprocal of 2 is 1/2. So in this third example, we're going to write an equation for a parallel set of lines. And we're going to write this equation in standard form. To get started, we need to know what slope we're working with, because that given equation, it's not just evident. We'll need to find the slope of x plus 2y equals 8. So you'd subtract x from each side, and then divide everything by 2. And now it becomes evident that your slope is negative 1/2. We'll substitute the slope and one of the points into the point slope form to find the desired equation. We'll substitute it in, that negative 1/2, because we want the same slope, because it is when your slopes are the same that they're parallel. So into the y1 we plug 3, and into the x1 we plug negative 4. Because we want it in standard form, we want integer values, we'll get rid of the fractions and write it in standard form. That would be by multiplying everything by 2, distributing that negative 1 into the parentheses, and then moving your terms so that they are in the standard form position. That would be by adding x to each side and then adding 6 to each side so that that constant value would be 2. You'll have just one x and two y's. In our last example, now we're going to write an equation for a perpendicular line. We're given the slope that we want it to be perpendicular to, and we're given a point that would be on the line. So again, we need to determine what slope we're working with. We want it to be perpendicular to 3, so we need to make it the opposite reciprocal. So the opposite reciprocal of 3 is negative 1/3. That is the slope we're going to work with for our perpendicular line. We'll use that slope and the point that was given, plugging them into the point slope form. So you plug 1 into the y position and 3 into the x position. And now we'll write the equation in slope-intercept form. Slope-intercept form, again, is y equals mx plus b. So distribute and move the 1 to the other side by adding. And there you have it. That would be a line perpendicular to a line with a slope of 3. And that's it. We'll do more practice together in class. Thanks for listening.